Hey guys, welcome back. We're doing the methods test of 2019 for probability and counting. Okay, so as in my past videos, it's just going to be running through the test question by question, skip through as you please, and I'll try and talk about some common errors and where I'm getting my answers from. Okay, so question 1. Given A, B, C, and D represent the probabilities in the region shown, so the probability of A and it's not B, so it's outside of B, is A, probability of A and B occurring, is B, so on and so forth. Probability is not A or B, is D. So we are trying to find the probability of A. Okay? Well, the probability of A is just whatever's in the A circle. So whatever's inside this A circle is A and B. So let me focus like that. So that's that part done. Part B, probability of A union not B. So this is probably worthwhile going through some of our set notation. Union and intersection. Union means or, intersection means and. Okay, union means it doesn't matter which one it is, it's taking all the possibilities into one group, and intersection means that it's got to be both of them. This one's union, so we're talking about or. Okay, so probability of A, which we already know is A and B, or not B. So here is B. We need to figure out what's outside of B. Okay, not B is anything outside. A and D, we already have A, so we can just add on the D. Part C, we had this little part, which that little straight line there is our conditional probability, and you can say it is given. So probability of not B given that it is A. That sneeze. Probability of not B given that it is A. So anything that is inside A is now our total, A and B. Alright, just a recap on our given probabilities. If you have probability of A given B, then it is the probability of B on the bottom, and I always put this little arrow here because the total becomes the bottom part here, and then both things have got to be occurring here, A and B. So we need to know where not B and A is happening. Okay, so just this part, A, is where it is not B. Let me just highlight B with a bit of anything outside that region is not B, which is A and D. Okay, the only part of that that is shared with A is little lowercase a there. So that's my top part. A is the total A and B together. Alright, question 2, we've got some factorials here. Okay, part A, we've got 11 factorial on 9 factorial. We're in a non-calc section here, so we need to be able to do this by hand. So what does 11 factorial mean? Well, that means it's 11 times by 10 times by 9 times by 8 times by so on and so forth until we get down to 2 times 1. Alright, I've just skipped out that middle bit because it is bothersome to write the whole thing, but we can recognize the pattern with the first part. And then the bottom part's going to be 9 times 8 times 7 times so on and so forth until we get to times 2 times 1. So this 9 times 8 times 7, 9 times 9 will cancel, 9 times, because we're multiplying, we can cancel both top and bottoms of my fraction. Any common factors to the top and the bottom can be cancelled. 9 is common to both top and bottom, 8 is common to both top and bottom, 7, 6, 5, 4, 3, 2, all of that cancels, leaving me with just 11 times 10, which is 110. Alright. This next part is, this is a way to write my choose function, so we need to be able to remember what that looks like. Okay, so n factorial over r factorial on n take over n take r factorial for anything that looks like that, or even that. Okay, this is my formula here. So 5 choose 2 means that I've got 5 factorial at the top and then 2 factorial, 5 take 2 factorial. Okay, so 5 times 4 times 3 times 2 times 1 on 2 times 1 times, this would be 5 take 2 is 3, so 3 factorial is 3 times 2 times 1, and then I can cancel a part of this. Alright, I can even cancel because there's a common factor between 4 and 2, makes that little part 2 there. 1 on the bottom line, this is just 5 times 2, which is 10. Okay, so linking this notation to your choose function is what we need to make sure we can do there. Alright, cancelling your factorials takes a bit of practice. Alright, Pascal's triangle. So, as a little recap with Pascal's triangle, okay, you're always going to start with zeros. So this would be the 0th row, 1st row, 2nd row, 3rd row, 4th row, 5th row. And when we talk about binomial expansion in a second, that number relates to the power. So 4th power would be technically the 5th row, 1, 2, 3, 4, 5. But because we start with 0, we talk about the 4th row here. Okay, and when it goes towards our choose, it starts with 0, 0, or then 1, 0, 1, 1, 2, 0, 2, 1, 2, choose 2, 3, choose 0. The left side always starts with 0, so 0, 1, 0, 1, 2, so on and so forth. 0, 1, 2, 3, 4, or 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. Okay, so our Pascal's triangle links directly to our, I may as well finish up this row now that I'm here. Pascal's triangle links directly to our choose function, so it could be the choose thing that I've done written next to Pascal's triangle here. So 1 is 0 choose 0. 3 here, let's say there, is 3 choose 1. We're in the 4th row technically, but because we started with 0, 3 here, so on and so forth. Anyway, so we're looking for 3 choose 2, or if you wanted to, 3 choose 2, written like that. So we're going 0, 1, 2, 3, and then 0, 1, 2. This is the number that we need to highlight for part C. Showing Pascal's triangle where 3 choose 2 is located. There it is. So again, 0, 1, 2, 3, and then 0, 1, 2. Alright, expand, part D, expand and simplify a 2 to the power of 4. Now, because Pascal's triangle links directly into my choose function and binomial expansion, okay, I know what this is going to look like. It's going to have 5 terms, okay, because it's going to have a to the power of 4, and then decreasing powers until a to the power of 0. 4, 3, 2, 1, 0 gives you 5 terms. Anyway, so it's going to start with 1, but right now we are looking at the numbers in this part of Pascal's triangle. 0th power, 1st power, 2nd power, 3rd power, 4th power, and then your 5th power. Okay, and then decreasing powers as you go across. So that will look like 1 times a to the power of 4. My coefficient would be 4a cubed, 2 to the power of 1. So now 2 is increasing in power as a is decreasing in power. And notice I'm using brackets to substitute in these terms. So in case it was 2a, I still put all of 2a in that bracket, because when it's applied, or when the 3rd power is applied to it, it applies to both parts. Okay, I'll have to try it a couple times to see what I'm talking about. But now I'll stick to this example. A squared, 2 squared, like that. Add 4a to the power of 1 to the power of 3. Add 1 a to the power of 0, which is just 1, and then it's just 2 to the power of 4 here. So I've matched the numbers of my Pascal's triangle. 1, 4, 6, 4, and 1. They're the coefficients. And then my first term in my bracket is, set of brackets over there, to the 4th power, and then decreasing, 3, 2, 1, and then 0. And then my second term is the power that's increasing, 0, then 1, then 2, then 3, then 4. Okay, but anything to the power of 0, the power of 0 is just 1. So that kind of disappears on the first and last terms. So now we've got to simplify, and I am running a little bit out of room, but I should be able to get this in. A to the power of 4 plus 2 to the power of 1 is 2, times 4 is 8, a cubed plus 2 squared is 4, times by 6 is 24, a squared is just a squared, 24a squared, plus 2 cubed, okay, is 8, times 4 is 32, a to the power of 1, which is just a, and then 2 to the power of 4, 2 cubed was 8, so 2 to the power of 4 should be 16. Okay. Let me just double check. 2, 4, 8, 16. Yeah. Cool. And then we're good for question 2. So with question 3, once I get it on the screen here, Victor has 16 books on the shelf in his room. He also has 24 books stacked up in his cupboard. So 16 on the shelf, 24 in his cupboard. Write mathematical expressions and then bold. Alright, always pay attention to the bold. Alright, you are not calculating the answers, so we just need expressions for the number of ways Victor can pick 4 books from his shelf. Okay, well, he has 16 books on his shelf, and we are trying to choose 4 of them. That's it. That's the expression. You could plausibly write 16, choose 4 like that. It doesn't matter in this case. Okay, we just want the expression. We don't actually need to work out what that is. It would be pretty big and we'd use a lot of factorials. Oh, could we work that out? No, it'd still be big. Anyways, part B. 3 books from his cupboard and 5 books from his shelf. So we're trying to figure out the number of ways Victor can pick. 3 books from his cupboard, 5 books from his shelf. Well, to pick 3 books from his cupboard is 16. 3 books from his cupboard. Scratch that. He's got 24 books in his cupboard and he's choosing 3 of them. Okay. And to pick 5 books from his shelf is 16, choose 5. And so the number of ways here, for every way that you've chosen 3 books from his cupboard, you have 16 choose 5 ways. To choose 5 books from his shelf, you can multiply these numbers to figure out the total number of ways for both of these things to occur at the same time. Alright. Part C, 13 books from both places. Alright. Now, having gone over this before, this is actually talking about a total of 13 books from both places. So, we are looking for, he's picking 13 books, choose, and then how many books are there in total? Well, there is 40. 16 plus 24 is 40. Okay. So in this situation, 40 choose 13 is 13 books from both places, both his shelf and his cupboard. Okay. Question 4, we have a two-way table. 300 people were asked which political party they voted for in the state election. Part A, complete the two-way table. So we've got heaps of gaps here in our two-way table. We're trying to fill it in. Okay. If there is a gap, depending whether it is a total or it is a part, then it changes how we do it. We can do 110, take 50, and get 60. 115 take 45 is 70. Okay. 300 take 140 is 160. So then we should have 50 plus 70 is 120 plus 40 is 160. That's working for us so far, so that's good. 60 plus 45 is 105, but we need a total of 140. So the other part must be 35. And this would be 75. Don't have to do it in the same order that I did, but you should get the same numbers regardless. Cool, we've completed the two-way table. Part B, what is the probability that a resident randomly selected from this group of 300 people here voted for Labour and was female? Well, there are 300 people in total, and we're basically thinking of the number of successes over number of outcomes. Okay, the probability of something happening. So how many females were there that voted for Labour? Females, Labour. 50 out of 300 people were female and voted for Labour. That's it. Part C, what is the probability that a resident randomly selected from this group was male, given they voted for Liberal? So the probability that they are male given that they voted for Liberal. Well, like I've mentioned before, the given part becomes your new total. So how many Liberal voters were there? Out of those 300, there was 115. How many of those 115, because now we're looking at just this section, Liberal voters, how many of them were male? And that's it for the non-calc section, I believe. Let me just double check. Yep. So that's it for the video. Let me know if you've got any questions, and look forward to seeing you next time. See ya.